Hi everyone, my name is Amitesh, and in this video we're going to talk about the binomial theorem or the binomial formula. Now the binomial theorem is a means of finding out the square of the sum of two numbers just in terms of those two numbers. And what we're going to do is we're going to talk about what the theorem is, how to just understand it, how to actually prove it using both geometry and algebra. So two different ways of looking at it, and I really love the geometry way. And it's in terms of areas of rectangles. And then we're just going to talk about some applications of it, like quick ways of finding out a bit complicated squares. Like for example, 23 squared or 37 squared just from the top of your head, or maybe 104 squared just from the top of your head. Okay, so using the binomial theorem. So let's just dive right into it and first off talk about what it is. Okay, so we have the binomial theorem. And this is a very important theorem in math. It comes up everywhere. And we want to really understand what this is saying because we're going to use this a lot. And even if you've seen it already, I hope there's some different ways of looking at it in this video that will be beneficial for you. Okay, so what is the binomial theorem first of all? So the idea is we want to take two numbers. I'm just going to write down 2 and 3 here. And we want to find out how to take the square of the sum of the two numbers. Okay, so in this case 2 plus 3 squared. Now, of course, in this case, you can say that you just want to add the numbers in the parentheses and then take the square of that. So here we would get 5 squared, which is 25. Okay. Now, what we want to do, though, is we want to actually get a formula just in terms of 2 and 3. And the first step that someone might do, and this is a very common error, in math, early math, where sometimes people write that 2 plus 3 squared, shouldn't it just be 2 squared plus 3 squared? I mean, this is like a question. You just kind of take the brackets and just square each of the terms and add them up. Now, unfortunately, this is not true because we can actually calculate that 2 squared is equal to 4 and 3 squared is equal to 9. So the sum is 13. Okay, so there's a big difference between 13 and 25. Now, what the binomial theorem is trying to do is to understand how far the actual answer is from just adding up the two squares. So there's an extra number that we want to understand, not just in this case, but in all cases. Okay? So for example, if I have, I'm going to write down the following expression, something like a plus b the whole squared. Okay, so here I have two numbers a and b. Okay, they can be anything. So I've denoted them by letters. They are variables. And I want a formula for a plus b the whole squared in terms of a and b. So here, of course, we could have just added 2 and 3 and found the square that way. But now I want a formula just directly in terms of a and b that works always, no matter what a and b is, and kind of starts off by saying a squared plus b squared plus something in terms of a and b. Okay, so that's what the binomial theorem is doing. And we're just going to understand this. Okay, so we're going to understand this from scratch. And I believe Newton discovered this. So if you think about this, although this is something that's used a lot in math nowadays, it took a long time for people to discover this theorem. There may be other people in history who've also thought about it in different ways. So don't quote me on the history exactly, but I do know Newton found a formula or understood this. And so it's a pretty important thing. But what we're going to do is we're going to start off by thinking about this geometrically, which is a way I really like to think about it. And we're going to draw a square and find the area of that square. Okay, so that's going to be the way we'll do this. So what we're going to do is we're going to draw a square. Okay, so here I'm going to draw, there are going to be two side lengths. So one side length is going to be A, and perhaps I will use some different colored markers here. Okay, another side length is going to be B. And what I mean by this is that the total side length of the square is going to be A plus B. Okay, so this is a square of side length A plus B. So I'm going to write that down, square of side length A plus B. And we're going to try to find the area of that square, and that's going to lead us to the binomial theorem. So this is going to be really cool. I'm going to split up the square into 4 pieces, okay? 4 rectangular pieces. Now the pieces are going to look like the following. So first I'm going to use the screen marker. I'm going to split it up into the following 4 pieces. So I'm going to draw it like this. And here what I've done is I've got 4 different rectangles. 2 of them are squares. Okay, so the first one is a square of side length A. Okay, it's going to be the top left-hand corner of this grid. Okay, The second one is going to be a rectangle of side length A and B. It's going to be the top right hand corner of this grid. And then the bottom left hand one is going to be a rectangle of side length B and side length A. Okay, so height is B, base is A. And then the bottom right hand one is going to be a square of side length B and side length B. So height and base are both going to be B. Okay, so we can write this in the following way as well, which may help. So I'm going to put this just to show you the symmetry. This is side length A, this also has side length A, and I can also write this here. This has side length B, and this also has side length B. All right, so that's going to be our diagram, and we're going to try to find the areas of each of the pieces in the grid. Okay, so each of these rectangles. So the first thing to observe is what is the area of the whole square that we started off with. So the area of the whole square is going to be the square of its side length, right? So area of a rectangle is base times height. And here we have the same base and the same height because it's a square, the big one. And its area is just going to be A plus B, the whole squared. Okay, so I'm just going to write this as area of the big square. Okay, so we can write this as area of big square. That's going to be A plus B, the whole squared. All right. So now what we want to do is we want to find the area of each of these rectangles one by one. Okay, so the first one I'm going to do, and I'm going to shade it black. What is the area? So let's say area, let's call this 1, 2, and 3, and 4. Okay, we'll split it up into 4 pieces so we understand what is area of rectangle 1. It's also a square in this case, but I'm just going to say it's a rectangle as well. Area of rectangle 1. What is it going to be? So in this case, we know it's a square. Again, its side length is going to be A. So its area is going to be A squared. Okay, so we're going to say area of rectangle 1 is A squared. What is the area of rectangle 4? Okay, I'm just going to jump right into 4. The area of rectangle 4 is the following. So area of rectangle 4. And I want you to think about this as I'm writing it down. Just try to say it in your head, you know, what you think the area is going to be. So in this case, the area of rectangle 4 is going to be, well, 4 has a base of B and a height of B. It's a square as well. And its area is just going to be B squared. Okay, so we can write this as B squared. So I'm going to keep the marker colors consistent. So B I've denoted with blue, so I'm going to write it as B squared. All right. So far we know that the area of the whole big square is the sum of the areas of the rectangles, and we've so far got 2 of the rectangles as A squared and B squared. So that's kind of the first part of the formula, is we're going to have A squared plus B squared plus something, and the something we've seen in this example, there is a something, right? You need to add something to A squared plus B squared. The something is going to be the areas of the rectangles 2 and 3. So that's what we're going to do, is find those areas. So let me write that down. What is area of rectangle 2 and area of rectangle 3? Okay, so I want to pause the video and ask you to work that out and actually say what the binomial theorem should be. Okay, so just do that and maybe leave a comment down below. You know, I'd love to see a comment down below, how you think about this, what formula you get. And if you have any thoughts or comments, you know, just drop one down below. Pause the video, work it out for yourself. What are the areas of rectangles 2 and 3? And what's the final formula going to be? Assuming you've done that, let's just dive into it. So area of rectangle 2, so I'm going to put this in a green marker. Area of rectangle 2 is going to be base times height, right? So rectangle 2, the height is going to be A, the base is going to be B, right? So here you can sort of see A and B. And so the area of a rectangle of height A and base B, doesn't matter what A and B are, it's going to be A times B. So we can write this as A times B. So I'm going to actually, again, sort of do it with the markers in a consistent way. So A with the black marker and B with the blue marker. And now, what is the area of rectangle 3? We've done area of rectangle 2. What is the area of rectangle 3? Well, that's going to be, I'm going to write it here, area of rectangle 3 well, that's going to be, again, base times height. And so here we have the base is A and the height is B, right? So base times height, it doesn't matter the order in which we multiply, you know, so we could say that if we're always thinking of it as base times height, we can say it's BA, or we can think of it as AB. It doesn't matter. So I'm just going to write it as BA, and there will be a reason I will write it this way. We'll see it in the other way we study the binomial formula, but it's the same as AB. Okay, so I'm just going to write this as BA. So it's just to indicate that for rectangle 3, the height is B, and for rectangle 2, the height is A. Okay, so I'm starting off by saying height times base. So here we're going to say it's going to be B times A. Okay, so let me write that down. It's B times, I just got a little jumbled with the markers, so it's going to be B times A. All right, so those are going to be the areas of the rectangles. So now the total area of the big square, which we know is A plus B the whole squared, is going to be the sum of the areas of all these rectangles, right? And that's just going to be, so we're going to get the formula A squared, okay, so rectangle 1. I'm just going to put this down here, rectangle 1, plus AB. So plus A times, okay, I'm just going to get rid of this green marker, plus A times B, plus B times A. Okay, so these two rectangles we just did, so A times B was the area of rectangle 2, B times A was the area of rectangle 3, and the last term was the area of rectangle 4, which is going to be equal to B squared. Okay, so we're going to write that down as just jumble up with the markers, so we're going to write this down as B squared. Okay, and here we're going to say that this is going to be rectangle 4. All right, so that's going to be the formula, and now what we can do is we can contract. We can say that AB plus BA, order of multiplication doesn't matter, so AB plus BA is just going to be 2 times AB, right? If you add something with itself, AB and BA are the same quantity. If you add something with itself, you'll just get twice that thing. Okay, so we can write the formula, and this is going to be the final answer. So I'm going to erase it here. This is going to be the binomial formula. So I'm going to write it as A plus B squared is going to equal to A squared plus 2 times AB plus B squared. Okay, so that is going to be the binomial theorem. All right, so that's the formula, and it's a pretty neat formula because it's basically told us the difference between the square of A plus B, taking A plus B and squaring it, and just squaring A and squaring B and adding them together, which is the first guess you would think maybe, if you first saw it, is actually twice A times B. Okay, so that's going to be the formula. And I really like this way because you can actually see the formula in action in terms of areas. So it's a very nice way of looking at it in my opinion. And that's the binomial theorem. Now what I'm going to do is, I've stated it this way, I'm going to briefly talk about the algebraic way of doing it, which is another way of looking at it and also important to understand. Okay, so we'll talk about that way. I just want to make one comment, and if this occurred to you, this may have occurred to you already, and it's a very important point. It's that in this figure, it's kind of not drawn to scale or not necessarily representative of all situations. For example, what if B was negative? Like what if in the binomial theorem we wanted to take 5 minus 3 and take the square, right? That picture, well, you can't have a negative side length, right? So that's an issue. And also this picture, it may seem that B and A, I've kind of assumed that B is smaller than A, right? So my answer to this, or my response to these kinds of comments are, so yes, this is an intuitive picture. It's there to help us understand one way of looking at it. And yes, it doesn't really handle the case of when the side lengths could be negative, which cannot actually happen. So it's not really general in that sense. The fact about it not being to scale, like A and B, the relative size, is not that much of an issue. This picture does give an adequate representation as long as A and B are both positive. It's the same idea even if B was bigger than A. But let's talk about the algebraic approach to understand, very rigorously why this theorem is true now that we've visualized it. Okay, so what we're going to do is we're going to think about, so this is the algebraic approach, so that was the geometric approach. The algebraic approach is we're going to take A plus B squared and we're going to write it as, well, what happens if you square a number, right? What does it mean to square a number? It means that you multiply the number with itself. Okay, so always in math, it's surprisingly powerful when you try to understand something. Just ask yourself what that thing is, right? Sometimes the dumb questions, they actually help propel you forward, or seemingly dumb questions. No question is really dumb. As long as you ask it, asking questions is always the first step. If you're stuck, ask questions. That means you're making progress. So here we have a plus b the whole squared. It's just a plus b times a plus b. Okay, so I've done another video. Check out all relevant videos in my channel. I generally keep the links down in the description below. I've done videos about multiplying, linear polynomials and understanding these kinds of expressions, which are quite relevant, but you don't need that video for understanding what follows. So here we have a plus b times a plus b. And now a plus b times a plus b, well, what happens when you take a plus b lots of something, right? When I say lots, like groups of something. So here a plus b is just the something. What happens when I take a plus b times something? Like for example, what happens if I have, something like 2 plus 3 times 7? What does that mean, right? 2 plus 3 lots of 7, it's 5 lots of 7, but you can also think of it as 2 lots of 7 plus 3 lots of 7, right? That is what 2 plus 3 lots of 7 is. Okay, so that is 2 plus 3 lots of 7. Now, the same idea applies no matter what a and b are, okay, whether it's 2 and 3 or anything. The idea is that a plus b lots of a plus b, or a plus b lots of something, is just going to be a lots of something, so a times a plus b, plus b times a plus b. And now, here I've sort of denoted it times. Typically in math with variables, people just don't put the times. It is understood when you combine variables together that you're just multiplying them. So here you can just write this as a times a plus b, just in the way I denoted that here. Okay, so here I've said ab, that's just a times b. Now we can further expand. We can sort of say that a plus b lots of a, right? That's what a times a plus b is. It's a plus b lots of a. It's going to be a lots of a plus b lots of a. So we can write this as a times a. So I'm just going to write it as a dot a plus a dot b. Okay, dot is multiplication. Okay, just to kind of show you the things multiplying together. And now we can say that b times a plus b lots of b. And I want you to try to finish this. Okay, so don't let me finish. Just try to think about what it should be and then pause the video and watch along. So what is a plus b lots of b going to be? It's going to be b times a. It's going to be a lots of b plus b lots of b. And now we know that a times a is just a squared, right? So we get a squared plus ab plus ba plus b squared. And this is why I kind of wrote down the ab and ba over there, just to show you that it's kind of a thing we take for granted, but it is true and important that the order of multiplication doesn't matter. Okay, so if we were living in a different universe where the order of multiplication mattered, then and there are such universes in math, it's in more advanced math, they exist, then you couldn't just say that ab plus ba is 2ab. Okay, but you can in this case say that. And here we can write, this is a squared plus 2ab, because something plus something is twice that thing, plus b squared. So that is going to be the formula, and this proof is a watertight argument. It did not matter if a and b were negative. Okay, so a and b are negative, it would have been the same formula. It's going to be a squared plus 2ab plus b squared, and that justifies what we saw intuitively, geometrically in that figure there. Okay, so there are many different ways of looking at it. If you have other ways of looking at the binomial theorem, drop me a comment down below. I'd love to hear it. There are so many different ways of looking at something in math, and it always helps to understand things in different ways and to play around with it. So that's what we're going to do now, is we're going to play around with this formula, and we're going to do two kinds of games with it. We're first going to understand what happens instead of a plus b squared, what happens if you take a minus b squared. Okay, so what happens in that case? And also we're going to use it to find some cool squares, like finding 23 squared or 37 squared or something like this right from the top of your head. Okay, so let's kind of do that. So I'm going to now erase the geometry which you just talked about, and you may have noticed I have this eraser. I really like it. It's kind of cool. It looks like an animal, but it's kind of nice and spongy, and it does its job. So we're going to erase it here. Now, just going to talk about, let's first, talk about the a minus b squared, just because that comes up a lot too. And it's actually the same principle. So there's nothing different about that. So that's kind of the important thing, that you can actually, in math, if you play around with stuff, you can get different ways of looking at things. You can get more, things that seem that if you had to individually work them out would be complicated, but actually they come as a consequence of something which you've already understood and done the work to understand, right? So for example, if I instead wrote down something like a minus b squared, okay, one thought could be that maybe we can just go through the same process we did earlier, right? We just went through a process of a plus b squared. We could literally just say a minus b times a minus b, and we could write it all out and get a formula. Okay, so I want you to do that actually as an exercise. Just try to do that and leave a comment down below, how it went and what you got. Because I think it's useful just to understand and practice with this concept. And I'll tell you the correct answer now, okay? What the correct answer is for that. So for a minus b squared, here's a quick way without going through all the process again or doing anything. Just from the formula we already derived, okay? So here's the quick way. What we're going to do is we're going to take the formula for a plus b squared first of all. Okay, so we've written that down there. Let's just write it here. So I'm just going to say a plus b squared. We know it is a squared plus 2ab plus b squared. Now what I'm going to do is observe that this formula is true no matter what a and b is. That is what is called an identity in math. It doesn't matter, you plug in any value for a and b, you're going to get a true answer. It's good to practice with that too. Just try some values. We will do that actually shortly. Okay, so you'll get a correct answer. What I'm going to do is I'm going to replace b by minus b in this formula. Okay, b can be anything. Let's just pretend b is minus b. Change the b to minus b and see how the right hand side changes. Okay, so when I do this, I'm going to get a minus b. So maybe I could write it down in the following way. I'm just going to put the blues to kind of show you what's going on, right? So a, now the plus b, we're just going to replace b by minus b. Okay, I'm going to put that in blue, and we're going to get a minus b squared. So what happens on the right hand side? If you replace b by minus b, again, like what do you think happens? Think about it, pause the video and think about it, and then we'll talk about it. So assuming you've done that, what we can do is we can say it's a squared plus 2a. So remember our game, we're replacing the b by minus b everywhere. So it has to be on both sides of the equation, because that's the equation is true for the b's being the same on both sides. So if we replace b by minus b on the left hand side, we also have to replace b by minus b on the right hand side, and we get 2a minus b. And then we're going to get plus, and then we're going to get, we replace b by minus b. So now that's the formula. We've literally just replaced b by minus b everywhere. That's what we should get. And now let's think about this. Okay, so the first observation is what is minus b squared, right? What is minus b squared? So anything squared is that number times itself, right? It doesn't matter what it is. So for example, so I can write this in the corner here, minus b squared is just going to be minus b times minus b. Now if you have two negative signs and you multiply them together, it becomes a positive sign. Minus 1 times minus 1 is plus 1. So we're going to get minus b times minus b is going to be plus, and b times b is b squared. So we can say it's plus b times b, which is b squared. So that's cool that b squared actually doesn't change. So this actually becomes, so that first of all we get this as a b squared. Okay? The a squared is whatever a squared is, it didn't change. But finally the 2a times minus b, well, what happens when you multiply 2a times minus b? Well, I always like to think of it, you're just putting the minus sign out front, right? So multiplication, order of multiplication doesn't matter. So minus b you can think of as b times minus 1. And if you're multiplying a bunch of things, you can just multiply the minus 1 first. And so you can think of it as putting the minus 1 out front. So you're just going to get a squared minus 2ab plus b squared. So that's going to be our formula. It's going to be a squared minus 2ab plus b squared. And that's going to be another version of the binomial theorem. And it is basically the same thing as the binomial theorem. It's just another way of writing it with a minus sign. And so that's the formula we're going to get there. And that shows you, how we could sort of think about this. You could kind of streamline that whole process. You can quickly sort of see that this is the formula we get from the binomial theorem. When we replace b by minus b, you get a formula for a minus b squared, right? So now what I'm going to do is I'm going to talk about some quick, cool applications of the binomial theorem that are kind of impressive. So maybe you can impress your friends and family. Just try to think about how to find some complicated squares. If you get good at it in your head, you just have to think about adding things rather than multiplying things. Okay, it's basically just a mental trick. So how does it work? So let's kind of erase this here. So the first step is it helps us maybe to find the squares of numbers that seem complicated. So for example, if I try to write down a number like 23 squared, right? How would we find out 23 squared? So, you can get good at doing this in your head. It's sort of multiplication, 23 times 23. But one cool way of thinking about it is in terms of the binomial theorem. Because the idea is that what square is 23 close to that we actually know, right? So 23 squared, it just kind of seems like, okay, what is that going to be? But on the other hand, if we try to find something like 20 squared, that's a bit easier because 20 squared, when you multiply 20 and 20, it's going to be 4 because the 2's are going to multiply, and then you're just going to add 2 zeros, right? So 20 squared is 20 times 20. You can just basically find the square of 2, which is, sorry, I shouldn't have written 40 there. You can just find the square of 2, which is easy enough, and that's 4. And then you just add on the 2 zeros. So you get 400, right? So that's going to be 20 squared. And then you need to figure out what to do to get 23 squared. And basically the idea there is you use the binomial theorem. So I'm going to write this as 23 squared. You can think of it as 20 squared. 20 plus 3 squared, right? And then the binomial theorem is a mechanism for allowing us to find the square of the sum in terms of the squares of the individual terms. And 3 is small enough, right? 20 we know. So we're just going to get 20 squared plus 2 times 20 times 3, right? So 2 times a times b. A and b are 20 and 3 here, right? So that's the formula. So it's going to be 2 times 20 times 3. So you can mentally think of it. A is going to be 20 and b is going to be 3. Okay, so you can think of it in the binomial formula. Okay, so we're going to get 20 squared plus 2 times 20 plus times 3 plus 3 squared. So we know that this is going to be 3 squared is 9. 2 times 20 times 3 is going to be 40 times 3, which is 120, right? You can do that. So it's going to be 120. So we're going to get 400 plus 120 plus 9. And that's just going to be 529. Okay, you can add them up. Adding up 400 and something generally can be done because 400 is like a nice, perfect, 100, multiple of 100. So you're just going to get 529 there. And that's a quick application. So that's 23 squared. The point is you can do this in your head if you practice it, and it's a quick thing, right? So for example, let's think about something just in our head. Okay, just to give another example, let's think about what is 32 squared going to be. Okay, so 32 squared is going to be 30 plus 2 squared. So we know 30 squared, 3 times 3 is 9, so it's going to be 900. And then the 2 squared is going to be 4. And then we're going to have 2 times 30 times 2, right? So 2 times 30 times 2 is 60 times 2, which is 120. So you add the 120 to 900 and you add the 4. So you get 1020 and then 1024. So I kind of did that, but just to show you that you can think about this in your head quickly, and you can do this with bigger squares too. Okay, so I encourage you to try to practice this out. Try to do some squares, and even using that formula. For example, if you had 27 squared, you could think of it as 30 minus 3, the whole squared. So sometimes subtraction is a little bit more complicated to think about than addition. We're used to addition, so I like the additive way, but you can do it that way too. You can find out 103 squared. Practice some. Let me know some down in the comments below, and try to sort of play around with it. So I'm going to end the video here. It's just a general introduction to the binomial theorem. I hope it helped you understand and feel for it, both geometrically, algebraically, and how it helps us to find, some cool squares. And just to feel for it, it's a pretty important theorem. Drop a comment down below. I'd love to hear from you. I'd love to hear any thoughts, comments, or feedbacks. And making this video meant a lot to me. I really enjoyed it. And my goal is to create free accessible math education worldwide. And liking and subscribing, it takes a second. It's free, just like watching is free. And even if you just watch this, it means a lot. But by liking and subscribing, you just give that extra thing to help my channel grow, to help it disseminate to more and more people who also love math and who also can benefit and learn from these videos. So thank you so much for watching. I hope you have a wonderful day wherever you are, and I wish you all the best. And I'm really looking forward to the next video, and I'll do my best to respond to as many comments as possible, and I'll definitely read all of your comments. So thank you so much, and I'm so excited to see you soon.